Mr. Harridan here. We're going to have a legendary lesson here about neutralization reactions.
Legendary.
Yes, very legendary. When an acid and base react together, they will form an ionic salt and water. Neutralization reactions, remember, are double replacement. So you're going to see acid plus base goes to water, which is always HOH, and N salt. Remember, the definition of a salt is any ionic compound. So in the generic case here, we're going to see an acid, which say that is HA plus and minus. We are going to see that with a base, which say that is JOH plus and minus. We are going to get our water, HOH, plus our JA. It's going to go together like that. Okay, remember, this is a special type of double replacement reactions. We have written these reactions before. So let's do the reaction of sulfuric acid and potassium hydroxide. Remember that sulfuric acid is the acid of sulfate. Okay, so we're going to have an SO4. Remember, sulfate is -2. Hydrogen is +1. So it's going to be H2SO4. Okay. Then we are going to react that with our base, potassium hydroxide. This is plus and minus. So we are going to add that to KOH. So we are going to end up with HOH, which is water, and our salt, which is KSO4. Remember that this is +2 and -1, so this is really K2SO4. Okay, so we're going to need a 2 right here to balance, and a 2 to balance that right there. All acids are aqueous, remember. This is group 1. This is aqueous as well. Water is a liquid. And potassium's in group 1, so this is aqueous as well. Okay. One thing I want to also teach you that's kind of important for AP here. This is strong acid. It's on the strong acid list. Plus strong base. It's on the strong base list here. We're going to have our water. Okay. And since this is strong and strong, no one wins here. This would be a neutral salt. So I would expect the salt pH here to be about 7. Okay. Let's do the next one. Calcium hydroxide. Calcium is Ca +2. Hydroxide is OH -1. So this is CaOH2. Phosphoric acid. Remember, this is the acid of, wrong color, Mr. Harridan. The acid of phosphate. So you're going to add this to HPO4. Remember, phosphate's -3. H is +1, so it's going to be H3PO4. And then when you mix these together, these get
neutralized.
They do. And you get the infamous HOH. And then you get your calcium with your phosphate. Calcium was +2, phosphate was -3. So there's a 3 here and a 2 here. We balance it by putting a 3 in front of here. That gets us 6 hydroxide, so we're going to need 6 waters. and 2 phosphates, which gives us 6 hydrogens there. Okay, state symbols again. This is a strong base, so this is aqueous, aqueous, liquid, and this will be a solid. Okay. If we look at our acid-base rules here, we see that this is a strong base. We add our strong base to our phosphoric acid is a weak acid. We made our water here, and since the strong base is stronger than the acid here, we would actually have a basic salt over here. Okay? Let's see what the next example is here. Lithium hydroxide. Lithium is +1, hydroxide is -1. This is LiOH. Chlorous acid. This is the acid of chlorite. Remember, chlorite is ClO2 minus. And since we are doing an acid, this is going to be HClO2. Okay? When we mix an acid and base together, what occurs?
Neutralized.
That is correct. It gets neutralized into water, which is HOH. And our salt here will be lithium chlorate. +1 and -1, so that's good. This reaction actually ends up to be balanced. That's good too. Lithium hydroxide is soluble. That's an AQ. We know all acids are AQ. Water is a liquid here. And since this has lithium, this would be an aqueous salt. Okay? So now if we look at the strengths of our acids and bases here, lithium hydroxide is a strong base. Chlorous acid is a weak acid because it is not on the strong acid list. We have our water, and since the base is stronger on this one, we again would have a basic salt on this one. Okay, last example here. Here we go. Aluminum hydroxide. Aluminum is +3, hydroxide is -1. So this is AlOH3 plus nitric acid. This is the acid of nitrate, which would be HNO3 +1 and -1. We are going to react these together.
Neutralized.
Yes, these get neutralized. And then we have HOH. And then our salt here would be aluminum nitrate. Remember, aluminum is +3. Nitrate is -1. Remember, you're not supposed to write those structures out there. 3 over there. 3 nitrate, so we need to put a 3 here to balance our nitric acid. 3 H's. 3 H's. So then we have 3 OHs. Okay, when we do our solubility rules on this one, if I remember right, this is technically a solid. This is technically aqueous. This is an acid. Water is a liquid, and all nitrates are soluble, so this is aqueous. Okay. Then we do our strength of our acids and bases here. We know that aluminum hydroxide is a weak base. It is not on our base list. Because remember, our strong bases are group 1 and group 2 hydroxides. Nitric acid is a strong acid. That is on the strong acid list. Okay. We have our water. And since our acid is stronger than our base here, we would have an acidic salt. So this would have a pH below 7, believe it or not. Okay, you guys are champions. The legend is